Hello, welcome to my YouTube channel, and in this video we are going to be talking about the present value. That's present value. That's what we're going to be talking about. Now don't forget, I've actually dropped some videos on simple interest as well as compound interest. So in this video here we're going to be talking about present value. So when we say present value, what do we mean? As the name implies, present value. The value here present. So there's a goal. So let me just give an illustration. I want to accumulate 10 million naira in the future. And let's say probably what's the future? Let me say 5 years time. I want to accumulate 10 million naira in 5 years time. So how much do I need now? How much do I need now? It might be an investment, of course, like I want to put a particular amount. Now that amount will grow in 5 years time. So we grow in 5 years time to 10 million naira. So how much will I need to be able to achieve this goal? So this particular amount that I need is the one that we refer to as the present value. You can call this the accumulated value. It's called the accumulated value, or it can also be called the future value. So this is the goal. My goal is to be able to accumulate 10 million naira. So how much will I need to be able to achieve that? Why this is called the present value. It's called the present value that will grow to give me this particular amount. Now, when you're looking at it in the case of the simple interest sense, in the case of the simple interest sense. Now, don't forget, now, if we are to get the, what do you call it now? That's the present value, this amount, times 1 plus IT. So let's say, for example, I want to be able to accumulate a unit amount, just a unit amount. So I'm talking about that's the basics of everything here. A unit amount. I want to accumulate a unit amount. That's 1. And how much will I need to be able to accumulate this amount? If we are looking at it in the simple interest. So of course, you are going to be given the interest rate as well as the duration. So like in this case, I'm having this amount. In this case, I'm having a unit amount. So what I want to get is a factor so that I'll be able to apply it in various accumulated values that maybe I want to find the present value. So I can say that x is equal to 1 over 1 plus it. So if I'm looking at it in the simple interest sense, how about in the compound interest? If it's a compound interest, that's to say the present value times 1 plus I raised to power t to get a unit amount, that is 1. So I'm going to say x, which will be equal to 1 over 1 plus I raised to power t. Now, t is the period of time, and would also take note of how it is being compounded. If it is compounded annually, if it is compounded quarterly. Now, I've actually I dropped that's a previous video on that, how to be able to look at the case of it being compounded quarterly or annually or any other case of compounding this particular value. So now the t is the number of times that we compound. And then in the case of the simple interest, the t is usually in years. So let's not forget that. So another thing that you need to know is that the discount factor, that is to say, we call this, some textbook make use of this to say this is 1 over a of t. And of course, we have so it means that the discount factor for the simple interest is 1 over I plus this t. Yes. So this is it. We have this and it's equal to this. That's in the case of simple. We call it this discount factor. And then in the case of compound, this is 1 over 1 plus I, and with the t, just exactly what I have there. So I'm going to refer to this as discount factor, while this is the case of compound. Now I'm taking note of this t. And then I would like you to know that in the case of this compound, we refer to 1 plus I to be equal to V. This is what we have. 1 plus I is equal to V. It can be written this way. or it can be written as 1 plus I raised to the power minus 1, which is equal to V. So we refer to this as the discount factor for the compound interest, and then this is also the discount factor for the simple interest. Okay, now looking at this question, we are going to solve this question. It says that the total amount of a loan to which interest has been added is 20,000 US dollars. Now, this is a word problem question. So what we are going to do is to be able to take the question sentence by sentence while we bring out the parameters. So first, it says that the total amount of a loan to which interest has been added. So you can see interest already been added to this amount. So it is that the total amount of a loan to which interest has been added. So this is the accumulated value. So I'm going to put this, the accumulated value, which is 2,000 US dollars. So now the term of the loan was 4.5 years. So you can see that the T is 4 years. And I'm going to say yes, 6 months, which of course I can either write it as 4 years, 6 months, or I can just write it as 4.5 years, as is written exactly in the question. Now, if money accumulated at simple interest at a rate of 6%, that is, this is a simple interest, and the money accumulates at a rate of 6%. So that's my interest rate, that's 6%, which is same as 0.06. Yes, so what was the amount of the loan? So in the first case of the question, so you can see I've been able to bring out all my parameters here. The accumulated value is this because it says that the total amount of a loan to which interest has been added is this. Interest have already been added here. So what is the amount of the loan, which is exactly what we are looking for. So you can see that in the case of simple interest, don't forget the value of T is usually in years. So we are going to maintain the years that we have here. So, and then I know that to find this, I would need the discount factor. The discount factor is what I'm going to use to multiply the accumulated value, and that will give me the present value. So the discount factor that I have here, let me write it this way, discount factor, sorry, which is 1 over 1 plus IT, with the T here. So that's what I'm going to use to multiply to get. So X is going to be the accumulated value, which is 20,000 times 1 over 1 plus I, which is 6%. So I have 0.06. And then my T, which is 4.5 years. So how am I going to put this? So I can say this is the same as saying, I think I could take it as 4.5 years. This can be converted to 4.5 years. Yes. So converting it to years, so I'm going to have this is 4.5. And then it's a little bit of calculator work. So I'm going to have this denominator here. Let me say 20,000 over. So I'm going to have 0.06 times 4.5 and then plus 1. So I'm going to have 1.27, which gives me, and so I'm having, this is for the unit here, 15,748.03. So this will be the present value that will be needed to accumulate 20,000 US dollars in 4.5 years' time. So this is the present value that will be needed. So if this is deposited in this simple interest account, in the next 4.5 years, it grows to 20,000 naira. So this is what we refer to as the present value. And that is in the simple interest sense. Now, how about the B part of the question? It says that if the annual rate of interest was 6% and interest was compounded annually, so you can see that it is The rate is still 6%, so we still maintain the same thing. That's looking at the compound interest. And of course, it is a compound interest, and it is compounded how? Annually. So we can see that it's compounded annually each year. So what was the amount of the loan? So that's exactly what we are going to do here again. I'm still going to get the discount factor in the case of the compound interest, and the discount factor, which of course we usually call that V, and it's equal to 1 over 1 plus I, and then the I is actually 6%. We still have this. I is 6%, which is 0.06. And then since I have this, so I'm going to say V, which is equal to 1 plus 0.06, and this gives me 1 over 1.06. Now, don't forget to get the present value is going to be the accumulated amount, which is 20,000 US dollars times the discount factor, which will be 1 over 1.06. But don't forget the value of t. Remember, it is, I usually write it this way. I write it like this: 1 plus I raised to the power of t. And then the t here is going to be the 4.5 years. Don't forget to still maintain the same thing. But now it is compounded annually. So here, what I'm going to have, I can still say this is same as saying 4 whole number 1 over 2, same as saying that will be 9 over 2. Yes, that will be raised to the power of 9 over 2. And when I calculate that, what I'm going to have is going to be 20,000 over 1.06. This can still be, of course, what I have here, 4.5. So I'm going to have 1.06 raised to the power of 4.5. And then 20,000 divided by answer. So I'm going to have, this is 15,386.99. So this will be the present value. Now, this is the present value in the case of the simple interest sense. This will be the present value. The same term, which is 4 whole number, 1 over 2 years, that's 4.5 years time, to accumulate to this particular amount. And in the case of the compound interest sense, I'm going to have this accumulating to this amount. So you could see that there's a difference here. For that of the present, for that of the compound interest, you can see that it is lesser than the simple interest, which of course it is true that as the number of years keep increasing, the compound interest tends to give a smaller present value. Here again, we have another question that says that how much should we invest now to receive 10,000 US dollars in 15 years and 3 months time at 5% interest being compounded annually. Now, looking at the question, we have to know that this is an investment. So we are going to be investing. So since it's an investment, it is usually taken to be a compound interest. Of course, it works for most of the, well, even though it has been stated here clearly that it is compounded annually. So how much should we invest now? So here, bringing out these parameters, I'm going to see that this is my accumulated value, and which is 10,000 US dollars. I want to accumulate this amount in 15 years, 3 months. So what's the duration? That's 15 years, 3 months. In 15 years, 3 months. And at a rate of, that's 5%, which is same as 0.05. And then we can see that it is being compounded annually. So since it's being compounded annually, so this can be converted to years. Now to do that, this is 15 years, 3 months. Converting that, that will be 15, and that will be plus 3 over 12. Yes, that's converting the 3 months to years. That will be 3 over 12. And that should give me 15, whole number 1 over 4, which is, of course, I can say it's equivalent to 61 over 4. So that's years now. So 61 over 4 years. So I'll be needing that to be able to find the present value. So they say, how much should we invest now? You can see now, which is the present value. Now, the discount factor for that is 1 over 1 plus I, and this is same as saying 1 over 1 plus 0.05, and so I have 1 over 1.05. So to find the present value is going to be the accumulated amount, which is what I have here, 10,000 US dollars times 1 over 1.05 raised to the power of the years. Don't forget that, and that will be 61 over 4. That's what I'm going to have. So this is small. A calculator works, so I'm going to have 1.05. That'll be raised to the power of 61 divided by 4. And so I have 10,123 divided by answer. So that will give me 4,751.86 US dollars. So this is exactly what will be needed to accumulate 10,000 US dollars in 15 years, 3 months time. So that's for the first part of the question. And for the second part of the question, it says also calculate its present value at time t equal to 2.5. So what does this simply mean? Let's think of it this way, that, okay, the period of time started from 0, but when the person got to time 2.5, that's say 2.5 years. So let's assume that there are two friends, and one started and then when it is 2.5 years, the other one had decided that, okay, I want to accumulate this amount of money. At the same time, when you'll be collecting yours, I also want to be collecting mine. So it means investment was done at 2.5 years, but the same accumulated value, the same accumulated value. That's to say it's 15 years, 3 months. Now, from 0 to 15 years, 3 months, 0 to 15 years, 3 months. This is the present value for that. But for this person is not starting the investment at the 0 years. The person rather is starting this investment at 2.5 years. That's 2.5 years time. And it will still run up to 15 years, 3 months. So think of it as a duration. Okay, fine. I think I can take that from here. This 0 and this is 15 years, 3 months. So at this particular period, so for the first case, we have the present value here running up to this. But then at this point, that's 2.5 years, this person decides to start the investment here to end at this particular point. So I think that's quite clear. So that's what it's saying. Also calculate its present value at time t equal to 2.5. So the parameters still remain the same, but then there'll be a little difference to the time. So I know that the I is the 0.05, but the time is not going to be, the duration is not going to be 15 years, 3 months, rather, because it's starting at this particular point. So I'll have to find the difference. So to say, when I converted 15 years, 3, that was around 61 over 4 minus 2.5, which is same as saying 5 over 2. That's 2.5. It's same as saying, remember, at time t equal to 2.5. This is same as 2 whole number 1 over 2 years. So that's what I have here. And having this value, this should give me, I have 5 year, and that will be 61 minus that's 2, 10. So it's 10 over 4, and that gives 51 over 4. So this will be the duration. So from here to this point here is actually 51 over 4 years. So that will be my value of t. So I'm going to go over this again and say the present value for this is going to be what I have here, 10,000 US dollars times 1 over 1.05 raised to power 51 over 4. Now this is power. So again, it's a calculator work. So I'm going to do that as 1.05 raised to the power of 51 divided by 4. And then 10,003 divided by answer. And so this will be 5,368.30. So this will be the present value for to accumulate 10,000 US dollars when the investment is done at time t equal to 2.5. So for this person who started at the 0 mark, the present value is going to be this. For this person who started at this point growing to this amount, this one growing to this, the present value from here will be this. The present value from here, it's going to be this. So you can notice that this is lower than this. And of course, it is expected. This should be higher because, of course, we know that the duration is shorter. So I believe that you get what I'm doing here. So don't forget to subscribe to my YouTube channel. I'm going to be dropping more videos again to help explain more of these ideas. So I hope that's good. Thank you.